In this video, I shall try to solve and explain some typical problems on dot and cross product of vectors in the vector algebra section. Watch this problem carefully. These three forces act at point P, whose position vector is this. We have to find the vector moment or the moment of the resultant of these three forces about the point Q, whose position vector is this. To solve this problem, we will apply this formula. The moment of force F acting at a distance r from a point is given by m equal to r cross F, where m is the vector moment, F is the force vector, and r is the position vector of the point where the force is applied, with the pivot point as the initial point of the vector r. In this problem, the three forces are given. We find the resultant by adding these three vectors, and we get force F. Here vector QP equal to vector R. Vector QP is calculated like this. Then we find the cross product by any method of your choice. Here I have found the cross product by using the determinant formula, and we find what is called vector moment, whose magnitude is this. Watch the next problem. Here it is given that vector A plus B plus C equal to 0. Mod A equal to 3, mod B equal to 5, and mod C equal to 7. We have to find the angle between vector A and B. You can solve the problem by many methods. The easiest way is probably this method. First, we write this equation. We are told to find the angle between A and B. So we keep A and B as it is and bring C to the right hand side. Now mod of vectors on both sides are equal, as well as mod minus C equal to mod C. Now squaring, we get this. Here theta is the angle between A and B. All other things are known, so theta can easily be calculated and found to be 60 degrees. Now let's come to the next problem. Here mod R is root 51. Vector A is this, vector B is this, and vector C is this. It is given that vector R makes same angle with vector A, vector B, and vector C. We have to find vector R. First of all, we will find out mod A, mod B, and mod C. All of them are found to be equal to 1. So here A dot R, B dot R, C dot R should be equal to one another, because angle theta and everything else is the same in all three cases. Therefore, in terms of components of vector R, we get this and this. From these two equations, applying cross multiplication rule, we get R1 by minus 5 equal to R2 by 1 equal to R3 by 5 equal to some constant mu. Now we put the value of R1, R2, R3 in terms of mu in this equation and find out mu equal to plus minus 1. Thus we get two sets of values for components of vector R. So vector R is this or this. Now let's see this problem. Here it is given that ABC is a right triangle and AB is the hypotenuse of length P. We have to find the value of AB.AC plus BC.BA plus CA.CB. This problem is very easy. Here vector CA and CB are perpendicular to each other, so this dot product is 0. Now BA equal to minus AB. Therefore this becomes AB.AC minus BC.AB, which is equal to AB.AC minus AB.BC, applying commutative rules. This becomes AB.AC minus BC, which is equal to AB.AC plus CB. But AC plus CB is equal to AB. So it is AB.AB, which means mod AB square, which is equal to P square. In the next problem, we prove the law of sines by vector method. For this purpose, we draw the triangle ABC like this. Here CB equal to A, BA equal to C, and CA equal to B. Now B cross A equal to A plus C cross A, because B equal to A plus C. This implies B cross A equal to A cross A plus C cross A by applying distributive property. This implies B cross A equal to C cross A, as because A cross A is 0. Again, C cross A equal to C cross B minus C, because A equal to B minus C. From here we get C cross A equal to C cross B. So these three vectors are equal. So we get this. When we divide each of these by mod A, mod B, mod C, we get the law of science formula. In the next problem, it is given that A cross B equal to C cross D and A cross C equals B cross D. We have to show that A minus D is parallel to B minus C, where AD and BC are unequal vectors. What we do? We subtract this equation from this equation and we get this. This implies A cross B minus C equal to C minus B cross D. This we get by applying distributive property. Now this becomes this by applying commutative property of cross product. This become minus. This minus 1 is multiplied as per scalar multiplication rule with this vector, and we get D cross B minus C on the right hand side. From this we get A cross B minus C minus D cross B minus C equal to 0, or A minus D cross B minus C equal to 0, which we get by applying distributive property. Since AD and BC are unequal vectors, therefore the vectors must be parallel. In the next problem, for any two vectors A and B, we have to show that 1 plus mod A square into 1 plus mod B square equal to 1 minus A dot B whole square plus mod of A plus B plus A cross B square. Now left hand side is equal to this. We apply Lagrange's identity and get this. Now we add and subtract to A dot B. This one becomes 1 minus A dot B whole square, and this one become mod A plus B square. Now A plus B and A cross B are perpendicular vectors, as A cross B is a vector perpendicular to both A and B. Now for any two perpendicular vectors we have this. Therefore using this formula we get the right hand side and we prove it. In the next problem, if ABC are the position vectors of triangle ABC of a triangle, then area of triangle is this. First we draw the triangle. Here BC equal to C minus B, BA equal to A minus B. Area of triangle formula is this. Applying this formula we get area equal to half mod BC cross BA. We put the values of BC and BA and apply distributive and commutative properties and achieve this. Now these three vectors are all perpendicular to the plane of triangle and are therefore parallel vectors. Therefore we may apply this formula and get the result.